Hello everyone. Now in this particular video we are going to discuss the execution of SQL code that is discussed in the lecture 2.4, that is module 9. Now in the previous lecture we have discussed about how to create table, how to insert a data in a table, and few DDL command we already discussed in the previous lecture. Now let's see what we have in this particular module. So if you observe in this particular module, we are going to discuss the Cartesian product first here, okay? Then rename operation, string values, order by, select, top or fetch. Then we have where clause predicate and then duplicate, okay? So few of the things we already discussed in the previous few tutorials, but let's quickly go through them also, okay? Now let us start with the basic operation first. So first one is Cartesian product here. So if you observe, so find the Cartesian product of instructor cross teaches, right? So we have an instructor table, we have a teachers table, and we are performing a Cartesian product between those two tables. Okay. What is the SQL query for this? Select star from instructor comma teaches. So if we see here instructor comma teaches, so if we specify table 1 comma table 2, it means we are performing a Cartesian product or cross join. Okay, so when we talk about the cross join, it will work same as a Cartesian product only. The difference between the cross join and Cartesian product is what? Here instead of just mentioning a comma between two tables, we specify here select star from instructor cross join. So we have to specify the keyword cross join and then teaches, right? So if you run this SQL query or this SQL query, the output is same. There is no difference. Okay. So cross join is basically a Cartesian product only. Okay. Remember this point. Now in the previous video at the end I have discussed this one, that if instructor has 10 rows and teachers has 5 rows, if we perform the Cartesian product between these two tables, so the resultant table it will have 10 into 5, 50 rows. Okay. So here you can see this particular thing, instructor teaches, if it had 10, if teachers has 5 rows, then here in the resultant table it will have 50 rows. So simply a combination of this first row with all the rows in the teachers table. Similarly, the combination of second row with all the rows in the teachers table. So you can observe here like this. Okay. So in this way we will get 50 rows if we have 10 in instructor and 5 in teachers. Okay. We'll try to execute this Cartesian product or cross join in SQL as well. Okay. Now examples here. Find names of instructor who have taught some courses and the course ID. Okay. So we need to find out the name of instructor along with the course ID here. Now if you observe, if we perform the Cartesian product, so resultant will be this particular table. But from this table, I cannot get any meaningful data. For example, if I have this particular row, so I have a instructor ID. So this particular thing is from the instructor table, Srinivasan Computer Science, 65,000 salary. But teacher's ID is different. Okay. So here you can see the ID is different, right? Course ID will be different. Section ID, semester, year. So if I want to find out which course ID teaches by the instructor Srinivasan, I will not get a data from this because I will get all the course ID here. Because what cross product will do, it will take first row and give the combination with all other row. So I am not going to get any meaningful data from the cross product. So what we need to do, we need to filter the output based on some condition. Condition is what? Here you can see where instructor.id equals to teachers.id. The instructor ID is here 10101. Now if I want to equate this to a teachers table here with teachers ID, so I have this particular 3 IDs here. It means that this particular instructor Srinivasan having this ID has taught these 3 courses. Okay, because I have 3 entries corresponding to this particular instructor, right? Here you can see this particular resultant table. So all these rows, this you can see these 3 rows are not meaningful. Okay, because there is no relation of this Srinivasan with all other this speech ID or course ID. So we are not going to get any meaningful data from the cross join. So what we do, we filter the result based on some common attribute here. Now in this case, we have a ID as a common attribute. So we are going to map the IDs from both the table, and then we are going to filter the output of cross join. So in this way, we are going to get the meaningful data. So if we perform this where clause, so this particular thing will get removed. Okay. So we'll discuss how it works in SQL as well. Again, for example, find the names of instructors in the art department who have taught some courses and the course ID. Now, if you observe, I want to find out the name and course ID. So, name I will get from instructor table, course ID I will get from teachers table. It means I need to use both the tables, right? Now, if I perform the Cartesian product here, instructor and teachers, so I'm not going to get any meaningful data. In order to get a meaningful data, we need to filter the output based on some condition, based on some common attribute here you can see. Okay, but here we have one more condition, that the department is art. So instructor dot department underscore name is basically art. Now from the art department I am going to get the name and the course ID of those instructors. Okay, so this is how the cross join will work. Now here if you see, it is equi-join or natural join. Okay, so we are going to discuss this thing in detail in the upcoming videos. But what is equi-join here? We are equating a common attribute here like this. Instructor.id from instructor table equals to teachers.id from teachers table, because then only the output will make sense, right? So this is about the Cartesian product. Now let's try to execute both the queries in the pgadmin. Now here you can see our pgadmin and query editor. So first let us look at the instructor table here. Select star from instructor. So if I select and execute this query, I am going to get the instructor table, and here you can see at the bottom we have 50 rows. So let me note it down here. We have 50 rows. Now let's select star from teachers. Let's see how many rows we have here. So here we have 100 rows. So here we have 100 rows. Okay. Now if I perform a Cartesian product between these two tables, tell me how many rows will be there in the resultant table. So instructor comma teachers, right? So we can do the calculation because we have both the data. Now let me run this query and see how many rows we are going to get it here. So if you observe, we got 5,000 rows. So 100 into 50, we got 5,000 rows. Again, if you observe this ID with this particular ID, there is no matching, right? So we cannot get any meaningful information from the cross product. So what we need to do, we need to perform an equi-join. Equi-join means what? We need to match the common attribute here. So here, where instructor.id equals to teachers.id here, right? Now observe here we have 5,000 rows. Now the moment I will add one more condition here, that ID must be same. Now let's see how many rows we will get. So we are getting 100 rows here. You can see here 100 rows, right? Because we are trying to map the ID from both the table. So in the output of this particular query, we have 100 rows. Now I am going to get a meaningful data, because if you observe this ID is same, instructor is same, because I can say that this name, because now I can get the information of this instructor Bondi, that he is from computer science department, salary is this, course ID is this, section ID is this, semester spring, and year is this particular thing, right? So I will get the entire information about this particular instructor if I just perform this particular condition. Okay, I hope you understand how this Cartesian product or cross join work. Same thing, if I just remove comma and mention cross join here, the output is same. There is no difference between this Cartesian product and cross join. Only the syntax difference is there. In Cartesian product, or we can say cross join, both are the same thing. Comma we use, or in cross join we simply specify directly cross join like this. Okay, so now if I execute this, here you can see 100 rows. Okay, now one more thing to note here, in the case of cross join, what I said, if my one table has 50 rows, other table has 100 rows, so in the output of cross join I will have 5000 rows, that is 50 into 100. But what about the columns? If I simply select this instructor table, how many columns we have? 4 columns, right? We have 4 columns. Now what about the teachers table? How many columns we have? 5 columns, right? Now what do you think, if I perform the cross product, how many columns I will get in the output of this cross product or cross join? So here you can see here, in total I will get 4 plus 5, that is 9 column. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the case of cross join, number of rows will be what? R1 cross R2, but number of columns will be what? C1 plus C2. Remember this important point. And here we are talking about the Cartesian product. We are not applied the where condition here for these cases. Okay, only the Cartesian product here like this. I hope you understand how this cross join or Cartesian product works. Okay. Now we have one question in the slide. This particular thing. Find the name of all instructors in the art department who have taught some courses and the course ID. So if I want to find out name and the course ID from the table, I will specify those attributes like this inside the select clause, right? So select name course underscore ID, but from which table? From instructor comma teacher. So here we have performed the cross product. So again, if I simply run this query, how many rows I will get? 5000 here, right? But I want to join these two tables based on the common attribute, that is basically a ID here. So where instructor.id equals to teachers.id. But we have one more condition, that I want those instructors who are from art department. So I'm going to filter this output based on one more condition, that instructor must be from the art department. Now if I simply run this particular thing, I will get 100 rows. But the moment if I add one more condition here, let's see how many rows we are going to get. So here we have 0 instructors from the art department. Okay. So if you see instructor, so we have this particular department, right? So I don't think we have any department called art. That's why we got this particular empty output, that is 0 rows here, right? You can see. So in this data set, we don't have any department by name art. That's why the output is empty. Now let's try to change the question with English. So instead of art, we will check for English department instructors. Now let's see what happens. So here I have 7 instructors from the English department. Okay. So this is how we can get a data using a Cartesian product, right? If I want a data from 2 tables, so first I can perform the Cartesian product, then I can filter the result based on the common attribute, and then based on my requirement, my condition, I can filter the output, right? So this is how this cross join will work. I hope you understand this particular concept. Now let's go back to our slides and let's discuss further. Now next is rename operation here. So if you observe rename as operation. So in the previous query, if you observe, every time I need to mention this one, instructor, teaches, again instructor, right? Because the table name, I want to specify that ID from this particular table, ID from this particular table, department underscore name from this particular table. But every time we need to mention the table name, so it will be complicated while writing the queries. So what we can do, we can rename this table name here. Okay. Now if you observe here, we have a rename as operation. So instead of mentioning the table name, what we can do, so I can specify like this, instructor as I, comma, teaches as T. And now instead of mentioning instructor.id, I can simply use I.id, here T.id, and here I dot department underscore name. So I don't need to specify the entire table name again and again. I can simply use this particular alias. Okay. Even if you can skip this as, you just need to use space and rename that particular table name. Okay. So let's try to execute this one in pgadmin. Now if you observe here, instructor, so instructor as I, teaches as T. So here instead of instructor, now I can use I. Instead of teaches, I can use T. Similarly here as well, right? Okay, now let's try to execute. So here you can see we got the same output because we have simply changed the table name here, right? We have just renamed the table name for this particular query. Even if you didn't specify this one as, you can simply give space and that particular new name. Okay, so you can remove this as well, just space and new name. So again, if you see, same output basically, right? So I hope you understand this rename operation. Okay, also we have discussed this rename operation in the select clause in the previous video. So instead of this course underscore id, if you want, simply id course or any names id underscore course, right? So if we do that, you can see in the output the name will get changed to id underscore course, right? So if you want to use any name in the output, you can use the rename operator here as well. Okay, now let's see here. Find the names of all instructors who have higher salary than some instructor in the computer science department. Now, if you read the question here, what we need to do, we need to compare the salary of one instructor with another instructor, because then only we can get the instructor who have higher salary than some other instructor, right, in the computer science department. So what query we can write here? Select distinct means it will give the unique name. T dot name, what is T? Let's see. From instructor as T and instructor as ES. So here we don't require a comma here, right? Now we are performing the cross product within the same table. Okay, both are the same table here, right? But here we are renaming it as T, we are renaming it as S, and now T and S are act as a different table, but data is same. Okay, and now here we are performing a condition that where T dot salary greater than S dot salary. It means we are going to compare one row with other rows from the other table. It's basically same table, but here we are going to compare with the T dot salary with S dot salary. Okay, and that salary must be greater than, so here we are using S dot salary, right? So S dot department name must be from computer science because higher salary than some instructors in computer science. Okay, so we are comparing with the S dot salary here. So from S dot department, it should be a computer science like this. Okay, so here you can see keyword as is optional and may be omitted. So we already discussed this thing, right? Now, one example here, Cartesian product example. So we have a relation emp underscore super. So person name and supervisor is given to us. So find the supervisor of Bob. So from table I can directly say supervisor of Bob is what? Alice. But how you can find out by using SQL? So simply I can mention select supervisor because I am just interested in supervisor column from that particular table name. Let's say employee underscore super. Now what? Where person is equals to Bob, because we are interested in finding out the supervisor of Bob. So where person is equals to Bob, right? So the output of this particular SQL query will be what? Alias, the required output for the first one. Now, what about the second one? Find the supervisor of Bob. So we need to find out the supervisor of Bob. We already know here the supervisor of Bob is Alice. Now the supervisor of Alice is what? David here. So output must be David, right? But how we are going to write a SQL query here? So what we need to do? We need to perform a cross product here, and then we need to compare the supervisor here. Okay. So this is a homework question for you. try to write a SQL query for this, and let's see whether you are going to get a David as an answer or not. Okay, this is a homework question for you. Now, third one is find all the supervisors, direct or indirect, of Bob. So all the supervisors means what? Alias supervisor is David. David supervisor, Mary supervisor is Susan. Right. So all the supervisors here. But for this particular case, for third case, you can try with the Cartesian product, or you can explore something called common table expression. Okay, so there is a recursion concept in SQL. Try to explore this particular concept, recursion, common table expression, recursion. Okay, and then you can easily get the answer for this particular case. But by using cross product also, you can try to find the answer for the third case. Okay, so first one I already done. Second one is pretty simple. Just perform a cross product between the same table like what we have discussed earlier and apply the condition. And third one is you need to explore about this common table expression and recursion concept. Okay, so please try to do this particular exercise. Now, what about the string operation here? So in SQL, we have various string operation, percentage and underscore. When I use percent, it means that the percent character matches any substring. Okay. Underscore character matches any character. So when I say one underscore, it means what? Only one character it can take. Only one character. When I say percentage, it can take any number of characters. Any number of characters. Okay. So how we use this percentage and underscore, that is string operation? Let's try to discuss that. Now here we use something called like operator. So we are going to discuss the concept of like operator here. Okay. So find the names of all the instructors whose name include the substring dar. So how we can find out the name of instructors that the name includes substring dar? For that we can use like operator here. So select name from instructors where name like. So here what? Percent dar percent. Now why we are using this percent dar percent? So what we want, name includes dar. It doesn't matter it is at the starting, at the ending, or in the middle, right? Dar, the dar must be present. So percentage will take care any number of character before that, and this percentage will take care any number of character after that. It will also take empty space as well, right? So here only we are trying to map with the substring dar only. So here name like operator we are using, then that particular condition. Okay. Similarly, match the string 100%. Now, if I want to match 100%, now if I use like operator 100%, now this will act as a this string operator. But I want to map with 100%, so that's why we can use this backlash as a escape character. Okay. Okay. Now you can see here string operation. Patterns are case sensitive. Yes. Pattern matching, for example. Now, if I just mention intro percent, so what it will do? First, it will ensure that we have this intro, and after that, any number of characters. So it will try to match any string beginning with the intro. Similarly, if I want to find out the name of an instructor starting from P, so in that case, P percent I have to use starting from P. If I want to find out name of an instructor ending with E, so in that case, percentage and E, because doesn't matter how many characters are there before E, but at the last I want E character only. Similarly, P, right? So here you can see if I want to match the string with the comp only, so here you can see percentage comp percentage matches any string containing comp as a substring. So if you observe, if I mention 3 underscore, so matches any string of exactly 3 characters. And here if I mention 3 underscore percentage, matches any string at least 3 characters, because this 3 underscore will ensure we have 3 characters, and this percentage will ensure that after 3 characters it can have any number of characters, that is basically at least 3 characters here. Okay. So this is about the string operation and like operator. So let's try to discuss this particular thing. Okay. Now like operator. So we already know we are going to use underscore and percentage sign here. Okay. So let's see an instructor table first. select star from instructor, right? Yeah. Now I want to find out the name of instructors whose first name start with P. So what I can do? So select star from instructors where name. So name like start with P, right? Capital P. So here, since name is a string data type, so we are going to use a single quotation here. So P percentage. So name starting with P here. That's it. So if you observe, name starting with P. So I can play with this percentage sign and I can get any data. For example, name start with R. So again, replace P to R. So name start with R. Now, name end with E. Let's try to find out that names end with E. So here you can see name ends with E. Now what if I want the name of instructors whose second character is E? Second character is E. So it means that there must be first characters, doesn't matter what it is. I want second character to be E. So E will be at the second space, and after that doesn't matter how many characters I have. So that will be a percentage. So name in which second character is E. So this is the correct way of getting that. So let's try to execute this particular query. So here you can see all the name of instructors having second character as E here. Okay. So this is how I can use like operator in SQL along with percentage and underscore symbol. You can practice on this like operator. We have one graded assignment question based on this as well. Okay. Now let's discuss it further. Ordering clause. Okay. Now, if you observe, list in alphabetical order the names of instructors. Now, if I simply run this select distinct name from instructor, right? So I'm going to get name of instructor, but it will be in not in sorted order. But if I want in a sorted order, what I can do, I can specify the order by clause. I can use this order by clause. So order by name. So here I didn't specify ascending or descending order. So if we didn't specify anything, so by default it is going to take ascending order, right? But if we want descending order, so we need to use DESC like this. Okay. So here you can see example order by name descending, and if I simply use order by name, so automatically it will be ascending by default. Okay. So all the names will be in the sorted order in ascending order. Okay. And we can also apply this order by clause on multiple attribute like this. For example, department name and instructor name. Now here you can see selecting number of tuples in the output. So select top clause is used to specify the number of records to return. Select top clause is useful for large table with thousands of records. Returning the large number of record can impact performance. For example, in instructor table, I have thousands of rows. But if I simply say select name from instructor, I will get 10 this much number of rows. But I don't want. I just want a top 10 or top 20 names from the instructors. So how we can do that? So for that we can use this top 10 distinct name from the instructors, right? But remember, for such scenario when we are dealing with the few rows top or limit clause here, not all database systems support select top clause. So SQL Server supports select top. So if you execute this on SQL Server, it will work. But MySQL, even PostgreSQL also support the limit clause here. So we are going to discuss how this limit clause works. Also, if we use Oracle as our database management system, so it uses the fetch first n rows and row number like this. So if I just run this query in the Oracle DB, I am going to get 10 rows in ascending order because first we have order by name. Okay, so let's try to discuss this one in the pgadmin. Now I am removing this one. So if I simply run this select star from instructors, if you observe name, so starting with M, P, M, L, M like this, so it is not in sorted order, right? So let's try to order by name. So by default it will be in ascending order. Let's see. So here you can see now I get the instructor name in ascending order. Arias, RNB, like this. Okay. Now here you can see I get the name in ascending order, right? Now I don't want all the 50 rows. I just want first 5 rows. So what I can do, order by name, then limit 5. I'm limiting my output with the 5 rows only. So first 5 rows is what? Till Baba, right? So let's try to execute this one. Yeah, so you can see I just got the first 5 rows. If we want the name in descending order and then 5 rows, so that will be like this, descending limit 5. So here you can see starting from Y we'll get the 5 rows. Now where we can use this order by clause. For example, you can see salary column here. Now if I want to find out the detail of instructors whose salary is in top 3. So in that case, what I can do, I can order by salary here. Now I need to use descending order because I want top 3. So descending limit top 3 here, and let's try to execute this one. So here you can see in descending order, I will get the salary of top 3 instructors like this. Okay. What if I want a name of an instructor with the second highest salary? The first one is this one. I want the name of an instructor with second highest salary. In that case, what you can do? You need to skip the first one, right? For that, we have offset. OFSET. Offset 1. So limit will give that particular number of rows. Offset will skip that number of rows from the top. Okay. So if I execute this, first we'll get skipped. So after first, I'm going to get the next 3 highest salary. But if I just want second one, so I just want one row. So limit 1, offset 1 will give me the second highest salary. If I want third highest salary, limit 1, offset 2 will give me the third highest salary. Right? Like this. But remember that in such scenario, if 2 instructors having the same salary, in that case, this particular query may not work, right? So in that case, we will go for a subquery or aggregate functions. So we'll discuss that in the upcoming lectures, okay? But as of now, just understand how this order by clause works, what is limit, what is offset. I hope this thing is clear. Now this thing will not work in PostgreSQL. You can try in respective DBMS, okay? Where clause we already discussed in the last video. So SQL includes between comparison operator. So find the name of all instructors with salary between 90,000 and $100. So between. So instead of mentioning where salary greater than or equals to 90,000 and less than equals to 100,000, we can use between thing as well. So name instructor salary then between 90,000 and so select name instructor salary between 90,000 and 100,000 like this. Okay. So this about the between operator. You can try this out in the PGAdmin. Now next we have tuple comparison. Now if you observe in the previous case, when we find out the instructors from our department, we have specified 2 conditions. Instructor ID equals to teach ID and department ID equals to biology. So we have specified 2 condition using and clause here, but we can also try out this particular thing as well. Okay, so let's try to execute this particular one. So we have already tried this particular thing. Now let's try to execute this one. Because we don't have our department, again we'll replace with the English. Yeah, so we got the output. So we can do like this as well. Okay, now next one is in operator here. What is in operator? So for example, if you want to compare 2 department name, computer science and biology. So what you can do, select name from instructors where department equals to computer science or department name equals to biology. But we need to specify this department name equals to this or equals to this, right? So instead of that, we can simply use in operator here. So we'll try to execute this one and let's discuss that. Now, for example, I want details of our instructors from biology and English department. Or let's say computer science and biology department. So what I can write, select staff from instructors where department underscore name equals to what? Let's say for example com dot science. Also I want department name biology as well. So I need to specify like this. Okay. For example, biology, right? So if I execute this query, so I'm going to get instructors from biology and computer science department. But what if I want three more departments? So I need to keep specifying like this, or department equals to English, or department equals to mathematics, like, right? So instead of doing that, what we can do, we can simply use in operator, and in the bracket we can mention those things. For example, com dot science, again comma, then biology. Okay. So instead of writing the column name equals to this or equals to this or equals to this, so we can use this in operator directly. Okay. So here you can see we got the same output. What if I want details of instructors other than computer science and biology? So except these two departments, I want information of all the instructors, right? From all the departments except two departments. So in that case, I can use not in here. So select star from instructors where department not in this department, computer science and biology. So if I execute this, so except these two department, I am going to get from the others department instructor. So here you can see the details, right? I hope you understand how this in and not in operator works. Also, it's not like that you have to specify the values inside the bracket. You can also use the select query here. So this can be a select query as well. Okay. So this thing we'll discuss in the subquery part. So output of the select query will try to match with the not in part. Okay. So we'll see how it works in the upcoming lectures. So in operator we already discussed. Along with that, not in also we discussed, right? Not in, you can practice or try to execute the same thing again using a in and not in with different department. Okay, then we have duplicates and this one. Yeah, so here we complete our lecture 2.4. We have discussed all the SQL code given in this particular module. I hope you understand the concept what we have discussed in this particular video, also how we can use this different things different things in our SQL query. Okay, thank you.